Imagine waking up one day to find your compass pointing south instead of north. It sounds like science fiction, but Earth's magnetic poles have flipped before, and they will again. This isn't just a quirky compass issue. A pole reversal could have significant effects. The magnetic field generated by movements in Earth's molten outer core acts as a shield against harmful solar and cosmic radiation. During a reversal, this field weakens, potentially exposing us to increased radiation levels. This could disrupt satellite operations, affect power grids, and interfere with navigation systems. Animals that rely on Earth's magnetic field for migration, like birds and sea turtles, could become disoriented. While life has survived past reversals, the implications for our technology-dependent society are profound. Earth's magnetic field isn't fixed. It has flipped many times throughout our planet's history. This phenomenon, known as a geomagnetic reversal, involves the swapping of the magnetic north and south poles. These reversals are not periodic, but occur at irregular intervals. The most recent full reversal, called the Brunch's Matsuyama reversal, occurred approximately 780,000 years ago. During such events, the magnetic field doesn't vanish, but becomes weaker and more complex, with multiple poles emerging temporarily. Reversals can take thousands of years to complete and are a natural part of Earth's geologic processes. Given that it's been a considerable time since the last reversal, scientists are keenly studying the magnetic field's behavior to understand what might happen if it flips again. Deep beneath our feet, Earth's magnetic field is generated by the movement of molten iron in the outer core. This movement creates electric currents, which in turn produce magnetic fields, a process known as the geodynamo. The rotation of the Earth helps organize these currents, aligning the magnetic field roughly along the planet's axis. This magnetic field extends far into space, forming the magnetosphere, which acts as a protective shield against harmful solar and cosmic radiation. Without it, charged particles from the sun, known as the solar wind, could strip away the ozone layer and harm life on Earth. However, the magnetic field isn't constant. Over the past 200 years, it has weakened by about 9%, and the magnetic North Pole has been drifting towards Siberia at an accelerating pace. This movement is believed to be caused by changes in the flow of molten iron within the Earth's core. While a weakening field could be a sign of an impending geomagnetic reversal, scientists emphasize that such reversals are natural and have occurred many times in Earth's history. Understanding the dynamics of Earth's magnetic field is crucial, as it plays a vital role in protecting our planet and maintaining the conditions necessary for life. Earth's magnetic field has flipped numerous times throughout its history. One notable instance is the Lost Champ event, which occurred approximately 42,000 years ago. During this event, the magnetic field weakened significantly and the poles temporarily reversed. Evidence from lava flows in France indicates that this reversal lasted about 1,000 years before the field returned to its normal state. These geomagnetic reversals are natural processes and have happened many times without causing mass extinctions. While some studies suggest that increased radiation during such events could impact life on Earth, there is no definitive evidence linking reversals directly to widespread extinctions. The process of a magnetic reversal is gradual, typically unfolding over thousands of years. During this time, the magnetic field doesn't vanish, but becomes more complex, with multiple poles emerging in different locations before stabilizing again. This gradual change allows many species to adapt to the shifting magnetic environment. Understanding these past events helps scientists prepare for potential future reversals. While a magnetic pole flip could pose challenges, Earth's history shows that life has persisted through numerous such changes. Imagine Earth's magnetic field as a protective shield, deflecting harmful solar and cosmic radiation. During a geomagnetic reversal, this shield doesn't disappear, but can weaken significantly by up to 90% at Earth's surface. This weakening allows more high-energy particles to penetrate the atmosphere, increasing radiation exposure on the ground. Such increased exposure could have various effects. For instance, it might impact electronic systems, as sensitive equipment could be more susceptible to radiation-induced malfunctions. While the direct link between increased radiation from geomagnetic reversals and cancer rates in humans remains a subject of ongoing research, the potential for health impacts cannot be entirely dismissed. Moreover, satellites and astronauts operating in space could face heightened risks. The South Atlantic anomaly, a region where Earth's magnetic field is particularly weak, already exposes satellites to higher levels of radiation, leading to malfunctions and data corruption. A global weakening of the magnetic field during a reversal could exacerbate these issues, affecting satellite operations and communications. In summary, while life on Earth has endured past magnetic reversals, the increased radiation exposure during such events could pose challenges to modern technology and potentially impact human health. Understanding these risks is crucial as we continue to rely heavily on electronic systems and space-based technologies. Imagine waking up to find your GPS isn't working, your phone has no signal, and the power is out. During a geomagnetic reversal, Earth's magnetic field weakens, making our planet more vulnerable to solar storms. These storms can disrupt satellites, power grids, and communication systems. For instance, a strong solar storm in 1989 caused a 9-hour blackout in Quebec, Canada, affecting millions of people. More recently, in 2022, a geomagnetic storm led to the loss of several Starlink satellites due to increased atmospheric drag. Navigation systems that rely on Earth's magnetic field, like compasses and certain aircraft systems, would need recalibration. The magnetic North Pole is already shifting towards Siberia, affecting navigation and requiring frequent updates to GPS systems. Without accurate magnetic data, ships and planes could face challenges in determining their positions, leading to potential safety risks. Our increasing reliance on technology means that a weakened magnetic field could have significant impacts on daily life. From disrupted communications to power outages, the effects of a geomagnetic reversal highlight the importance of understanding and preparing for these natural events. Many animals, such as migratory birds, sea turtles, and whales, rely on Earth's magnetic field to navigate during their long journeys. This ability, known as magnetoreception, helps them find their way across vast distances. For instance, sea turtles use the magnetic field to travel thousands of miles and return to the same beaches where they were born. If Earth's magnetic field were to weaken or flip, these animals might become disoriented. Studies have shown that disturbances in the magnetic field can cause birds to stray from their migration paths, a phenomenon known as vagrancy. Similarly, whales have been observed to strand themselves on beaches, possibly due to following magnetic anomalies on the ocean floor. However, it's important to note that Earth's magnetic field has flipped many times in the past, and life has continued to thrive. These reversals occur gradually over thousands of years, giving species time to adapt. Many animals use multiple cues for navigation, such as the sun, stars, and landmarks, which can help them adjust to changes in the magnetic field. In summary, while a magnetic pole reversal could pose challenges for migratory animals, their adaptability and use of various navigational tools suggest they would likely adjust over time. Let's clear up some common misconceptions about Earth's magnetic pole reversals. Myth 1. Earth will physically flip or rotate differently. This isn't true. A magnetic reversal involves a change in the planet's magnetic field, not its physical orientation. The planet continues to spin on its axis as usual. Only the magnetic poles switch places. Myth number 2. Pole reversals cause mass extinctions. There's no definitive evidence linking magnetic reversals to mass extinctions. While some studies suggest that events like the Lost Champ excursion 42,000 years ago may have coincided with environmental changes, the overall fossil record doesn't show a consistent pattern of extinctions tied to these reversals. Myth number 3. The reversal happens suddenly. In reality, magnetic pole reversals are gradual processes that unfold over thousands of years. This slow transition allows ecosystems and human technology ample time to adapt to the changes. Understanding these facts help us appreciate that while magnetic reversals are significant geological events, they are not catastrophic. Life on Earth has persisted through numerous such reversals, and with our growing scientific knowledge, we're better equipped than ever to monitor and adapt to these natural changes. Over the past 200 years, Earth's magnetic field has weakened by about 9%. This gradual decline is a natural part of the Earth's magnetic fluctuations. One notable area of concern is the South Atlantic Anomaly, or the SAA, a region where the magnetic field is significantly weaker. Located over parts of South America and the South Atlantic Ocean, the SAA allows more cosmic radiation to reach closer to Earth's surface, posing challenges for satellites and spacecraft that pass through the zone. While these changes might seem alarming, it's important to understand that magnetic pole reversals are slow processes. If a reversal were to occur, it would likely unfold over thousands of years, giving ample time for adaptation. In summary, the weakening magnetic field and anomalies like the SAA are indicators of Earth's dynamic magnetic nature. However, there's no immediate cause for concern, as any significant changes would happen gradually over millennia. As we wrap up this journey through Earth's magnetic mystery, here's what we know. Magnetic pole flips are completely natural. They've happened many times before and will happen again. In fact, the last major one occurred about 780,000 years ago, long before smartphones or satellites, but well within the time frame of early humans. And guess what? Life kept going. Yes, a reversal would bring real challenges. Our technology could face disruptions. Satellites and communication systems might need major upgrades. Animals that rely on Earth's magnetic field could get confused for a while, and we'd likely have to adjust how we navigate, protect ourselves from increased solar radiation, and maybe even rethink how we build certain systems. But it's not the end of the world. Earth's magnetic field doesn't just switch off. The process is slow, likely taking thousands of years. That gives us time to adapt, innovate, and prepare. After all, humans have always been great at adjusting to change, just like we've done through ice ages, solar storms, and everything in between. So while a future flip might sound scary, it's more of a long-term shift than a sudden disaster. Scientists are watching closely, and we're already building smarter systems to handle whatever comes next. The truth is, Earth has flipped its poles before, and life has always found a way to move forward. The compass may one day point south, but life will always find its way. If you found this video fascinating, hit that like button, subscribe for more deep dives into science and space, and let us know in the comments what topic should we explore next.